Let's go through our exponent rules. If I have a base to some power times the same base to a different power, I add them. For example, if I have x cubed times x squared, this is equal to x times x times x, that's x cubed, times x, that's x squared. And if I count them, I have 5 x's. If I have this to some power to a power, now I multiply. What makes this different? Well, if I have x squared to the third power, that's the same as x squared times x squared times x squared. And then x squared is x times x, x times x, x times x. If we count them, we'll see we get x to the 6th power, which is multiplication. If I have a base to a power divided by a base to a power, this is the same as subtraction. Why does that work? Let's say I have b to the 5th over b squared. Well, this is b times b times b times b times b. And I'm going to divide by b times b. Well, I know I can cancel these b's and these b's. And what do I end up with? I end up with b to the 3rd power, which is 5 minus 2. If I have a times b to the m power, that's the same as a to the m times b to the m. So I'll just say xy to the 3rd power. Well, that equals xy times xy times xy, which equals x times x times x is x to the 3rd, y times y times y is y to the 3rd. So we can see that we really just distribute that exponent. Any base to the 0 power is always equal to 1. This is very important. Let's look at y. Let's say I have 7 to the 4th power. That's the same as 7 times 7 times 7 times 7. And I divide both sides by 7. I'm going to use my rule for division, and I subtract 1 from this side, and then that gives me 7 times 7 times 7. If I divide both sides by 7 again, I get 7 squared equals 7 times 7. Divide both sides by 7 again, I get 7 to the 1st power equals 7. Divide both sides by 7 again, and I get 1. Anything to the 0 power is equal to 1, except b cannot be 0. 0 to the 0 is not 1. Other than that, now, why did I want to do that first? Because we have these rules for negative exponents. For example, if I have b to the minus m, that equals 1 over b to the m. How does that work? Well, let's see. This is really the same as b to the 0 minus m. This is b to the 0 minus m, no issue. When I use my division rule, notice I subtract. If m is 0 and n is some number, that's really the same as b to the 0 over b to the n. This is the same as b to the 0 over b to the m. Because if I subtract, I get 0 minus m. Well, anything to the 0 power is 1, and I get b to the m. Something to a negative exponent is always it actually just changes position. Because the same thing is true if I say 1 over b to the minus m. That's going to equal b to the m for the same reasons. I just don't want to go through all the steps. It's not that important. But I'm going to make up a really hard problem. And then I'm going to show you what I want you to do. And when you see it, it'll make it so easy. Let's say I have x to the minus 2 times y cubed times z to the minus 5 times a to the minus 1 divided by x squared y to the minus 5 z to the 4th a to the 3rd. That looks pretty scary, right?
Yes.
It does? Good. Now watch how easy. This is equal to, first thing I want to do is I want to put my fraction bar. Anything that's negative is going to switch positions. What I mean by that is I start with x to the minus 2. Oh, it has a negative exponent. I'm going to put it in the denominator and make it positive. Y to the 3rd, positive, stays where it is. Z to the minus 5th, negative, has to change position. A to the minus 1, negative, has to change position. Now I'm on the denominator. X squared, positive, it's got to stay x squared, right where it is. But y to the minus 5th is negative, it's got to change position. Z to the 4th is positive, but it stays right where it is. And a to the 3rd is also positive, it stays right where it is. They never make the number negative. Did I make anything negative here?
No.
I made all my exponents positive. When we have a base to a power times a base to a power, we add the exponents. Now I'm going to collect all my x's. Here's an x squared, and here's an x squared. X squared times x squared is x to the 2 plus 2, which is 4. Now let's look at our z's. We have z to the 5th times z to the 4th. That is z to the 9th. And then we have our a's. A to the 1st, I have 1a, and then I have 3 more a's. That gives me a to the 4th. I have now, and I've simplified it from this really scary looking thing. Now everything's positive. If I have negative 3 squared or negative 3 squared, the exponent only affects what it is next to. For example, well, the squared is only next to the 3. It's nowhere near the negative sign. So that means this is negative 3 times 3. Because we're squaring just the 3, this becomes negative 9. This, however, is next to the parentheses. This is really the same as negative 3 times negative 3. I square what's inside the parentheses. And this gives me positive 9. That is a very important rule that. So now